Yeah.
If you see in math, we always write f of x a lot, and that is the function. Okay.
Yeah.
Now the trend is we write y is equal to f of x. That's pretty standard.
Mm-hmm.
And we use x and y axis. So this is an x axis, this is the y axis. Okay. Now there are some standard functions. Okay. For example, I can write f of x is equal to sine x. Now this is a standard function. Another example would be f of x is equal to e to the x. Let's talk about the first one first. If I say f of x is equal to sine x as a function, now this function simply looks like this. Do you know this?
Yeah.
Okay, so this is called as a sinusoidal waveform or a sine function.
Okay.
Now, how do you basically plot this function? You can take various values of x and find out f of x for that. For example, say if x is 0, then you put 0 here, and we know that sine 0 is 0. Then next you put some standard value. Don't put 1. 1 is a bad number to put. Rather put pi by 2, pi over 2, and the
Yeah.
sine pi over 2 becomes 1.
Okay.
Now, how do I plot that? The first one, which is 0, 0, I told you, right, that f of x is nothing but y.
Yeah.
Y is f of x. So you have x as 0 and y as 0, and that is this point here.
Okay.
Now, next is x is pi over 2 and y is 1. And
Mm-hmm.
then pi over 2 comes here. Okay, that's the x value pi over 2. And the y value is 1. That's this point here.
Okay.
So keep getting those points, keep putting different values here, and keep getting this function. That's typically how a function looks like.
Okay.
Okay. Now this was just one example. Now I want to talk about one more example, and that's the last one. Say if I have f of x is equal to e to the x. Now this is another standard function in math, and this function looks like this. The horizontal axis is x, the vertical axis is y. We know y is f of x. That's pretty standard in math. Okay. And if I want to find out f of x equal to e to the x, this is nothing but y equal to e to the x. Then you can make a table like this. You can write down x and y. Now put x equals 0. Do you know what is e to the 0 is?
No.
Oh, e to anything to the 0 is 1.
Oh, okay. Okay. Makes sense.
So that's 0, 1. Can you tell me how do I plot 0, 1?
So
X is
it
going to
would.
be 0
Yeah.
and y is going to be 1. This is y, right? And now
Yeah.
this point here is going to be 0, 1.
Yeah.
And now you just can go on putting some different values. Say if you put x is equal to 1, that goes here.
Yeah.
You get y equals e raised to 1, e power 1.
Is 1.
That's just e,
Oh, E. Okay.
right? So now do you see x is 1 and y is e? How do you plot that? X is 1 and y is e. By the way, e is 2.72.
Oh, how do you know that?
Oh, that's a standard. Like e,
Oh,
it's
okay.
like pi. Pi is 3.14. Like that, e is 2.72.
2.72. Okay.
And it just never repeats. It continues till infinity.
Okay.
Yeah. So which I just remember like, two values after the decimal. Anyway, so that 2.72 is going to be higher than 1. It's going to be somewhere here.
And 2.72. Yeah.
Yeah.
Makes sense.
It's bigger than 1 for sure.
Yeah.
Right. Put 2 and then it becomes e squared. Do you see if I put 2 here,
Yeah.
y becomes e squared.
Yeah.
And e squared is going to be square of this, which is going to be way bigger. It's going to be somewhere here. So if I just connect the dots, I get a function something like this.
Okay.
So these are basically standard functions. So now I'm going to give you a quick recap. Okay. Now here are the things that you have to remember. Okay. These are pretty standards. If you have doubts, you can ask me. I can always go in details and tell you everything about it. I can tell you why is 2.72, but it's just not,
Yeah.
it's
Yeah.
I mean, it's just going to
Not
be,
important.
yeah. So first point that I want you to note, this green one, is you remember y is a function of x. That's how we write it always. That's pretty
Yeah.
standard. Okay.
Okay.
And then the examples of standard functions and how do you plot those functions.
Okay.
And then I've given one more example. I have plotted that as well.
Okay.
So it's basically x and y is plotted over here.
Yeah.
Okay. Now, what this does is, function is a way of representing real life in math. For example, let's say, I don't know if I can give you any biological example, but I can give you a lot of technical engineering and computer science examples. This is
Okay.
X and this is Y. Okay. Now, supposing if, what example can I give you? If I have X versus Y, you can have X as electricity and
Okay.
Y could be cooling.
Okay.
You live in Canada, so AC is not very relevant to you, but in
Yeah.
India it is. So you have X is electricity and Y is cooling, right?
Yeah.
So when your electricity is little, your cooling is little.
Yeah.
That's this point. When your electricity X value is like 100, very high. Do you see this is 1 and this is 100?
Yeah.
The cooling is going to be very high, say 1000.
Okay.
Okay. And I just like, plot all these points here. Okay.
Yeah.
And I can just like connect them
Mm-hmm.
and I can say, hey, uh, say I have a Samsung air conditioner. And
Okay.
for that, the relation of its electricity versus cooling is written like this. So that's y is equal to e to the x. Do you see it's very similar to this?
Yeah.
So now, for a layman, I mean, for someone who doesn't know, it is just y is equal to e to the x. But for Samsung guys, okay, this is nothing but a AC. Now this graph over here, this whole thing is a representation of the air conditioning that they're making in a
Okay.
mathematical way. So what
Mm-hmm.
we basically try to do with the function is right now here in this box here. What we try to do is we try to model real life situations in the
Mm-hmm.
form of a function.
Okay.
Okay, so this function, though it looks like y equal to e to the x, or you can say f of x equal to e to the x, all that is good. But now behind the scene, this is literally representing an air conditioner. And now who would care for this? A Samsung, say, company will definitely care about, how
Yeah.
this function is.
Yeah.
Yeah, and they would really want the AC to be very, power efficient. So they want to make sure that this graph is in a certain way so that the bills are not exorbitant for people, so
Yeah.
that they can sell more. Okay, and this is just one example out of like everything under the sky is a relation of the two terms. I can give you
Mm-hmm.
many more. I can just
Yeah.
replace this x. It's a variable, right? The idea of variable, it varies.
Yeah.
So can I say x as a fuel,
Mm-hmm.
and then I can say this is a distance,
Okay.
and this is nothing but a Toyota,
Yeah.
right? I can simply say this is electricity and this is distance. Now this graph is the Tesla. Are you
Yeah.
are you are you getting what I'm trying to do here?
Yeah.
I'm trying to get all the real life physical objects and
It makes
mapping them
sense.
in a mathematical function, and that's what the function is all about.
Okay.
In the function, we are trying to model, a real life situation
Yeah.
in some form so that we can actually, and why would we do this? I mean, why would I want to plot the electricity taken by a car versus a distance traveled? Because
Mm-hmm.
that is basically a range of a car, and that really matters to Elon Musk, right?
Yes.
So these things are very important, and we get them in a mathematical form, and as soon as you get them in this particular form, you can actually do a lot of R&D, or you can make your car better, or you can find out a lot of good insights so that you can develop a better product.
Okay.
I'm very sure that you can have this as electricity. I mean, I don't know. This could be any two biological terms. They are related to each other. Like for example, it like an ECG, right? I'm just trying
Mm-hmm.
to give you your relevant example.
Yeah.
ECG is the what is basically a functioning of a heart. So you have X is time and
Yeah.
Y is the heart activity,
Yes.
and that's basically I can write this as f of x,
Yeah.
and that is the ECG, EMG, whichever one you want to call it. They're all functions essentially.
Yeah.
And those functions have a valuable information, right? Because this, when you look at it, you know the heart condition of that patient.
Yeah.
So that's basically a foundation of the function. Now on top of this, we have like so many things that we can do. Like there are different types of function, there are different ways of writing function, all that is coming up. Okay, but then this is the overall big picture of the whole story.